All right, so in this video, I am going to work out number 9 on page 20 in your packet. So the first thing we need to do when we're following our steps is we need to factor and then simplify. All right, so that's step 1 and step 2. So when we factor the numerator, we get x plus 4 and x plus 3. When you factor the denominator, you get x plus 7 and x plus 4. So now we need to cancel anything out that will cancel. So the x plus 4's cancel, and that leaves me with x plus 3 over x plus 7. That's my simplified function. All right, so now I need to figure out, well, what are my wholes? All right, so to get the wholes, it says to set the canceled out portion, which is x plus 4, equal to 0, and solve for x. So I get negative 4 because I would subtract from both sides. All right, now I still need to get the y value. So to get the y value, I have to substitute back into the simplified function. So I would have negative 4 plus 3 over negative 4 plus 7, which gives me negative 0.3 repeating. All right, so my whole would be negative 4, negative 0.3 repeating. So negative 4, negative 0.3 is what I'm going to put. All right, so that's my whole. So now I'm going to go to my graph, and I'm going to go to negative 4 and then down just a little bit. All right, so that's my whole. Now I need to find the vertical asymptote. All right, so for the vertical asymptote, you need to set your denominator equal to 0. So x plus 7 equals 0, and I would just solve for x, which would give me negative 7. So remember before we would talk about extraneous solutions? Well, that is my extraneous solution, all right, and it gives me an asymptote. All right, so remember, an asymptote is just that imaginary line that your graph approaches. All right, so now we want to look at our horizontal asymptote. So we have to figure out, is it top heavy, bottom heavy, or equally heavy? And it doesn't matter if you use the original function or the simplified function. We have a 2 and a 2 for our exponent, and we have a 1 and a 1 for our exponent. Either way, it's equally heavy. So the horizontal asymptote would be y equals the leading coefficient over the leading coefficient. All right, so the leading coefficient, whether I use the original or the simplified, is 1 over 1, which is, of course, 1. So y is equal to 1. So again, that is another asymptote. So I'm going to go to y equals 1, and I'm going to have a dotted line for that horizontal asymptote. All right. Now we need our x-intercept. So for the x-intercept, it says we need to set the numerator equal to 0 and solve for x. So for my x-intercept, I would say x plus 3 equals 0, solve for x, and I would get negative 3. So my x-intercept is negative 3, 0. So I'm going to go ahead and plot that point on my graph. The last thing is the y-intercept. All right, so for the y-intercept, I have to substitute 0 in for x. And I can use the original function, or I can use the simplified function. It doesn't really matter. So I would have 0 plus 3 over 0 plus 7, which is 3/7, or a decimal would be 0.4. And the only reason why I'm looking at the decimal is because it's a little bit easier maybe for you to plot the point. All right, so that is my y-intercept. So 0 and then up a little bit, right? Almost halfway. All right, so now this is where we kind of go beyond what I'm expecting for you in this class because of remote learning. So for your assessments, you're going to have to be able to identify the whole, the vertical, the horizontal asymptotes, the x and the y-intercept. All right, but for this video, I do want to show you the graphing just in case, okay, because I do want you to see how you would get that graph. All right, so remember, you want points in each region. All right, so, and everything is going to kind of go, you know, zigzag. So these points are down here, which tells me I'm going to have something up here, because this is bottom right, top left. You know, it's got to kind of alternate. All right, so the points that we have here is enough to sketch my graph. All right, but I would like to typically put it in my calculator and get some whole numbers if I can. All right, so I'm going to go to my table and do n over d, x plus 3 over, oops, let's try that again, over x plus 7. And it doesn't really matter where you start, okay? But I'm going to look for some whole numbers. So I have negative 3, 0, which I already plotted that point anyways. Oh, I have negative 5, negative 1. So I'm going to go ahead and put negative 5, negative 1. That's right here. I have negative 6, negative 3. So 1, 2, 3. I have, oh, here's a couple more. So negative 8, positive 5. And negative 9, positive 3. Negative 11, 2. That's a little bit off my graph, but I can go ahead and plot it. Okay, so that gives me plenty of points to get a good sketch of my graph. All right, and I like to use the whole numbers. If I have to, I would use some of the decimals or the fractions, but this is plenty. All right, so remember, these points are going to approach the asymptotes, but it's not going to go through the hole. It's going to kind of jump over the hole. All right, so I kind of have like a boomerang looking graph over here, and then you'll notice all of these points, they just curve towards their asymptotes as well.